Hi, I'm Daniel Kashabi, and I'm going to present our NACL work on discretized interpretation of continuous prompts, or prompt waywardness. This is a joint work with my wonderful colleagues at University of Washington, Allen Institute for AI at University of California, Irvine. Unless you were disconnected from the internet in the past few years, you know about all the excitement around large pre-trained language models. There are many exciting things about these models that are well beyond the scope of this work. One thing in particular that is quite exciting about these models in the context of natural language is their emergent ability to respond to language commands. We can apply language prompts on these models in order to solve well-defined tasks that we care about. Just as a toy example, suppose I want to classify sentiment of a bunch of movie reviews. We know that we can prepend a language prompt that defines our task to an input, in this case movie reviews, to which models may answer with positive or negative. A key nice property of discrete prompts is their interpretability. Since language is a convenient medium of communication, this enables average humans to interact with models and form expectations about their internal behavior. This is very nice. The challenge here, though, is that we don't have efficient algorithms for finding most effective prompts. And this is a key bottleneck if you want to build models that maximize your desired metric for whatever application that you want to build. In parallel, there is also a line of work on continuous prompts, typically defined as a vector of the real valued numbers prepended to the embedding of an input text to make the model generate a desired outcome. For example, a continuous prompt that can effectively solve the task of sentiment classification. It turns out that continuous prompts are complementary to their discrete counterparts. We have really efficient algorithms for finding good continuous prompts. However, meaningful interpretation of continuous prompts as a natural language is an open problem. Maybe this particular prompt has something to do with sentiment analysis. Maybe not. It's really unclear. So motivated by this complementary behavior between continuous and discrete prompts, we are interested in the research question of whether there are any meaningful discrete or textual interpretation of continuous prompts. Since we don't know how to address this question head on, we actually study the opposite problem, which is how unfaithful can the interpretation of continuous prompts be to what they actually accomplish. To make it more concrete, we investigate whether there are any continuous prompts that perform a desired task while at the same time they project to a given target text, such as the definition of a different task. In this case, I'm showing the definition of negating sentiment of a given sentence. Now you might ask, what do I mean by projection? In our experiments, we use nearest neighbor projection of continuous prompts onto word embeddings via dot products, which is a common choice in the field. For example, it is used when decoding text from neural generative language models. Though later on I'm going to argue that the results that I'm going to show here, they hold for a wide variety of well-defined projection functions. Now here I'm going to jump ahead of myself and tell you that our finding is that indeed the opposite question posed here is correct, which is what I formally call the waywardness hypothesis, which states that one can find accurate continuous prompts such that they can be projected to any arbitrary text. This essentially suggests that there is a disconnect between the outcome of continuous prompts and their discrete interpretation. This is really the key message here if you want to remember one thing from this work. Now for the rest of my time, I'm going to show you some experiments and findings in this work. We do a series of experiments where we compare the performance of two prompts. A prompt that is trained to solve a particular given task, let's call it P star, and another prompt, let's call it P tilde, that is not only trained to solve a given task, but it is also forced to project to a given task that we provide as part of the input. These arbitrary texts can be definition of a different task. We have collected about 30 of them in this study. Or they can also be random sentences that we have sampled from the web. We also have a variety of these sentences. Now, empirically compare the performance of these two continuous prompts on a downstream task. The intuition here is that if the continuous prompt has something inherent in it about the task that it is solving, by forcing it to project to an irrelevant text, it should suffer in terms of task accuracy. In practice, what we observe is that it is possible to find continuous prompts that project to any given text, meaning high token overlap, while suffering only tiny bit in terms of their end task accuracy. And this is not just for sentiment analysis. We repeated similar experiments across a variety of different benchmarks and observed similar trends. All of these are basically an empirical support for waywardness hypothesis, which is one can find accurate enough continuous prompts even though they project to completely different given text in the input. Moreover, the accuracy gap between these two prompts decreases as models become larger. In other words, the larger the models get, the less interpretable the continuous prompts that we get from them become. Yet another pragmatic concern in using these large language models. There are more experiments in the paper that I won't get into, and instead I'm going to use the remainder of my time to share some intuition that enable waywardness. Now, let's try to make sense of waywardness. Why is this happening? The first issue is that the mapping between continuous and discrete spaces is not one-to-one. While each discrete prompt is mapped to exactly one continuous representation, the reverse is not true. There are many continuous prompts that project back to a fixed discrete prompt. This indicates that there is a whole region of continuous prompts that correspond to a fixed representation in discrete space. This statement is actually true not just for our choice of projection, but rather for many well-defined choices of projection well beyond nearest neighbor projection that we have tried empirically here. There are more theoretical arguments on this in our paper. Now, the remaining question is, how can this tiny region be so rich that it can solve a variety of tasks? And the answer to that is the expressivity of large language models with respect to their inputs, which also includes continuous prompts. It is the combination of these two forces that, to our understanding, is giving rise to waywardness phenomena. Now, before I end, let me just quickly enumerate several implications of waywardness. The immediate issue is concerning continuous prompts. As I argued, faithful discrete interpretation of continuous prompts via common discrete projections is unlikely to be robust based on current modeling paradigms. Whether there is a better construction of continuous prompts is an open question that the future work should address. And if we do not build effective interpretation for prompts, there can be social risks in a future where model development is driven by fine-tuned prompts. Consider the following scenario. A model designer comes up with a continuous prompt for a high-stakes problem. For example, ranking resumes according to each applicant's merits. Such prompts may contain biases targeting minority groups, intentionally or otherwise. And naive efforts to interpret these models, they may indicate benign statements which may not reveal the true nature of their behavior. And they can actually be exploited to create a false sense of security or fairness. And the last point that I would like to highlight is regarding discrete prompts. As I mentioned in the beginning, optimizing over discrete prompts is an open question. You may wonder, why is that the case? Turns out that our finding on continuous prompts can help us understand this difficulty. Think of your favorite continuous optimization formulation in search of discrete prompts. It may look something like this. It is an optimization problem over word distributions with two objective functions, a utility term to maximize the downstream task objective, and another objective for maximizing the fluency of the resulting text. You may look at this and say, hey, this looks like a reasonable optimization problem to solve. Why don't we just solve it and call it a day? The issue, and I'm going to be a little bit hand-wavy here, is that this is a degenerate optimization problem, meaning that there are infinite many prompts that maximize both utility and readability, though the resulting prompts, they're actually not faithful to their resulting effect. And this is yet another technical implication of the waywardness phenomena. Let me summarize. We started with the waywardness hypothesis, which is a surprising difficulty in interpreting continuous prompts. And we provided empirical evidence and intuitions for this hypothesis. And finally, we concluded with the implications of this hypothesis. My hope is that the observations made in this work, they will motivate future algorithmic or architectural innovations that will lead to effective prompts that are faithful to the task that they can solve. Thank you for your time.